The ethanethiol is also called ethyl mercaptan, is commonly added to natural gas to provide the rotting gas of a gas leak. The boiling point is 35 degrees centigrade and its heat of vaporization is 27.5. So I know from the values given already that the delta G is what is the entropy of vaporization for this substance? So I know that the delta G is equal to 0 because at this point, at the boiling point, this is the point at equilibrium. So delta G is equal to 0 and delta H is the 27.5. This is the value at which 1 mole of heat is changed from a liquid into gas. And delta S is the entropy of the vaporization that's required to find. I know that delta G is equal to delta H minus TO multiplied by delta S. So I can find out easily putting this as 0 and this as 27.5 and temperature changing by adding into 273 to find as Kelvin instead of degrees centigrade. Then I can find easily by math the delta S, which is equivalent to 89.3 kilojoule per mole per Kelvin. Don't forget to change the 27.5 kilojoule per mole into joule per mole by multiplying it by 1000 because this one has to be changed into mole, so I can also compare it to the delta S. Okay, for mercury, the enthalpy of vaporization is 58.51 kilojoule per mole, and the entropy of vaporization is 92.92 joule per Kelvin mole. What is the normal boiling point? So I have the delta H, 58.51. I have delta S, entropy of vaporization. I need the temperature at which there is boiling, at which the delta G is equal to 0. Delta G is equal to delta H minus T delta S. I will bring the T alone. So the other side it would be positive T delta S equal to delta H and delta G here. Anyway, delta G is 0. Delta H will change it into joule instead of kilojoule by multiplying by 10 to the power of 3. And then delta S is 92.92. Do the division, you will get 629.7. In this similar question, for ammonia, the enthalpy of fusion is given in kilojoule. I multiplied by 1000 as usual to change it into joule. And delta S is given also. And saying at temperature 200, does it melt? So does it melt is looking at the melting point for it, changing from the solid into liquid. So again, he's giving the same equation, delta H is equal to delta H minus T delta S, and try to find what is the value of delta G here. I found that the value of delta G is equal to minus 130, which is a negative value, so this means that the reaction is spontaneous and that it's going to melt. But in number B is asking what is the value exactly of the melting point. So the melting point is the temperature at which it will melt, and this 200 is more than the melting point, so of course it will be already melted. So let's see, the number should be coming less than 200. So let's see, or equal to 200. Maybe this is the value of the melting point, or equal or less than 200. So I'll find delta G equal to delta H minus T delta S, like the previous question, and find T delta H minus 0, because delta G at the melting point is equal to 0, and over delta S after the changing into joules. Then I'll get the value equal to 196, which is correctly less than 200. So this means that at temperature 200, you are already melted, you have changed it into liquid, and more than that is solid. So at 196, you are already, let's write it again, this is 200 degrees. At anything which is more than 200, you have melted, changed it into liquid. At anything less, you are solid. So what is the approximate melting point? So what is the approximate melting point of ammonia? The melting point is 196. And 200, of course, will be melted at it, so A was correct also.